Okay, so just having a look at differentiating between language such as 3 times as much or 3 times as many and 3 times more. So in this demonstration, you can see this one here on the left, 3 times as much as the amount on the bottom. So if we've got an unknown quantity, we have 3 equal parts that are 3 times as much as the one on the bottom. Whereas over here on the right, we've got 1 equal part on the bottom, and the amount above is 3 times more or 3 equal parts more. So we can see that we've drawn 3 extra parts, each part the same size as our B down the bottom. So just looking at these, is this 3 times as much or 3 times more? This is 3 times as much, 3 times as many at the top compared to the bottom. Whereas this one here is 3 times more because there's 3 more parts. So just going through the difference, 4 times as much as the bottom, whereas this one here is 4 times more because there are 4 more parts compared to what we have at the bottom. Okay, so putting that into some problem solving is Paula was 3 times as old as Brennan. If Brennan is 18 years younger than Paula, how old are Paula and Brennan? So we start by circling the key numbers, underlining the question, and boxing the key math section words. And then we start to draw, and we use a comparison bar model like we saw. So Paula is 3 times as old. Brennan's age, we have Paula's age, which is 3 equal parts compared to Brennan. Okay, and what we do have is we do have the difference between their age. The difference between their age is 18 years. And the difference between their bar models is Paula has 2 extra parts. So we use those extra parts compared to Brennan to represent the extra years of age. Okay, now for Paula's 18 years, there's 2 equal parts that are worth 18. So we need to divide that up equally, and in this case we divide it by 2 because there are 2 equal parts. 18 divided by 2 is 9. Each of these rectangles represents 9 years of age, which means Brennan has to be 9 years old. And if Brennan's 9 years old and Paula is 3 times older, Paula needs to be 3 times 9, which is 27. And we can double check that because 27 take away 9 does equal 18, so we know that that's correct. So Paula is 27 years old and Brennan is 29 years old. So if we move over and have a look at this one, Georgia spent 2 times more on her groceries than Annie. If Georgia spent $64 more on groceries, how much each did they spend? So circle key numbers, underline the question, box the key maths words, and we start our bar model again. And this is showing 2 times more because we have that we've got Annie's amount, Georgia has the same amount plus 2 equal parts more. So that's the difference between 2 times and 2 times more. And Georgia spent $64 more. So the extra gets labelled with the amount of money she spent more than Annie. So once again, we have 2 equal parts, so we divide it by 2. So 64 divided by 2 is 32. So Annie spent $32, and Georgia spent 3 equal parts of $32. So to find that, we multiply 32 by 3, and that ends up with $96. So Georgia spent $96, and Annie spent $32. So the solving is actually quite identical. It's more just pulling apart the 2 times more versus 2 times or 2 times as much wording. But one thing I just want to show you too, if we go back to that first question, is how this links to algebraic thinking. So as we saw here, we had 3 equal parts, 1 equal part. And another way we can think about it to solve it is if we have 3 equal parts in this blue and we take away our red equal part, we're left with 2 equal parts that equal 18, and then we can solve it that way. Each equal part equals 9, which is what we did. We can also use letters like we do in algebra, and the most common one is x, and really all it means is unknown number or equal part. It doesn't mean, and that's where the confusion often comes in. So in this case, 3x take away our x at the bottom. So 3x take away x equals 2x, which equals 18. So 2x equals 18, divide each side by 2, and x equals 9. So that's how we can start to link it. We're representing algebra, we're just not using the letters to represent unknown numbers, we're actually drawing unknown numbers or equal parts. So hopefully that's helpful, and that's what we've been working on for the last couple of weeks, and we'll do a couple more weeks working on that in the classrooms at school.